We have two interconnected areas, and area 1 is losing 1000 megawatts of load. So when you have a change in power, you'll also have a change in frequency. So your generators are going to react based on droop control. Droop control is basically the gradient that tells you how much power your system needs to generate to make up for your change in frequency to keep the system stable. So the frequency of our system is 50 Hz. And for a 1% change in frequency or 6% change in frequency, we're going to have a percentage change in load and percentage change in the output of the generators. So what do we know for area 1 and area 2? They both have 1000 spinning reserve megawatts, a bias factor, and it's area 1 that loses 1000 megawatts. And area 2, 10% of the generators are blocked. So that means we only have 90% of the generators available to respond. So what can we write? Let's start with area 1. So we can find that we have 24,000 megawatts left and for generation, and also 1000 megawatts spinning reserve, which means we have 25,000 megawatts available to react. Then we can find the droop response. Area 2, generation, so we have 41,000 megawatts, and we also have 1000 megawatts spinning reserve. So we have 42,000 megawatts available to react. What else do we know about area 2? 10% of the generators are blocked. So that's going to be 0.9 times by 42,000, which is 3,780 megawatts available to respond. So now we can find the droop response. So if you look here, droop response, one second. So droop response is 1 over R. So for area 1, it's going to be for regulation. So we're dealing with the generators. And it says that a 6% change in frequency leads to 100% change in output of the generators. A 6% change in frequency, so 0.06, 6% change in frequency, the frequency is 50 Hz, leads to 100% change in output of the generators, which is 25k. So that's going to be 8,333 megawatts per Hertz. For area 2, what's the droop response? Same thing, so for a 6% change in frequency, we have a 100% change in load, 42,000. So that's 12,600 megawatts per Hertz. So for the total droop response, our total is going to be 1 over R1 plus 1 over R2, which is 20,933 megawatts per Hertz. Okay, so let me copy this. What else do we need? What else? So, what's this? We've dealt with this part, now let's deal with this part. So, we know that when frequency changes, your generators react. And also, the frequency dependent load is gonna increase. So if we calculate this for each area, it's gonna be for area 1. So for area 1, we know that a 1% change in frequency leads to 100% change in load. So a 1% change in frequency, the frequency is 50 Hertz, leads to a 1%, this is meant to be 1%, not 100%, leads to a 1% change in load. So 0.01, what's the load? Now we're dealing with the load. So for area 1, 25,000, but we're losing 1,000, so it's going to be 24,000. So that's 480 megawatts per hertz. Now once again, for area 2, we know that a 1% change in frequency leads to a 1% change in load. So for area 2, we have 1% change in frequency of 50 Hertz, 1% change in load, and the load for area 2 is going to be 40,000. So that's 17 megawatts per hertz. So your total damping of the load in area 2 and 1 is 1280 megawatts per hertz. What are we actually trying to calculate is the new frequency of the system. So let's calculate the change in frequency first. So the change in frequency will be the loss of load, so minus PL, divided by the reactance of the generators plus the damping of the load. So that's 1000 megawatts lost divided by these, which we have calculated here, and you get 0.045 Hertz. This is also known as your stiffness of the system, so B. That's the change in frequency. But we want the new frequency. So the frequency new is the old frequency of 50 Hertz plus the change in frequency. So we have 50.045 Hertz. Why is it plus and not minus? Because we are losing load. So your frequency has to increase. Okay, what else now? What else? Yeah, so we need to find the load in each area. So the change in load, and change in generation. So the change in generation is going to be the damping. Damping is for the change in load times by the change in frequency of the system. We found the damping here, damping of area 1, damping of area 2, and the change in frequency of the system is this. So you're going to get, for area 1, you do it for both areas. So area 1 is 21.6 megawatts, and area 2 is 36 megawatts. So load 1 21 24,000 and 21.6 megawatts. So we had 24 for damping, for load. So we had 24,000 megawatts left after losing 1,000, and we're going to have to add the change in load. So this, and same for the second area, 40,036 megawatts, because in area 2 we had 40,000 megawatts, and we have to add the change in the load of 36. So it's that. Now for generation, change in generation power, we're going to do the droop response, because that's what corresponds to generation. This corresponds to the loads. So this times by the change in frequency of the system. Once again, we have a change in droop response for area 1 and for area 2, because we need to do it twice, times by the change in frequency of the system, which is this. So you get minus 3.75 megawatts minus 567 megawatts. What's happening here? Generation is turned down because the frequency is also going down. So we're going to have to subtract from generation 1, and generation 1 is 24,000. We're going to subtract this change in generation, so you're going to be left with 23625. Yeah, and this one for area 2, initially we had generation 41,000, and we're going to have to subtract 567. So you're left with 40433 megawatts or something like that. So yeah, now one more thing we can find out, tie line losses. So for area 1, we're going to have the generation minus the load. So generation area 1 minus load, you're going to be left with 396.6 megawatts missing because it's minus. And for area 2, so generation 2 minus the load at 2 plus 397 megawatts, you have extra. So this should be approximately the same, but we lost some during calculation because of approximations like this. So yeah, this is for tie line losses. You can just subtract them.